Right, we're looking at trigonometry, trig equations, and this is mainly grade 11. You need to have actually acquired some skills before this in grade 10, but now we're adding on some stuff. First, let's just touch base, how to use a calculator. Very important, you learned that when you're finding a ratio, you would have been given an angle, so you just punch everything as is. For instance, sine 80 is just 0.984, which is easy and straightforward. There are a lot of other digits that come after that. Obviously, you would have been asked to round off accordingly. But when we're solving equations, you're actually finding an angle given the ratio that would have been in the equation. For instance, cos x is equal to 0.652. We're given the ratio is 0.652. We need to know what angle gives that ratio, and that now you are looking for in an unknown. And here the order of punching things is shift first, the trig function cos, and then the value on the other side. Now this is very important. You're always going to be getting your calculations in your equations to that stage when it's ready for a calculator, and that's when then you can punch a calculator. You don't just punch a calculator, you have to look very carefully at an equation. If it needs to be manipulated first, sort out things until it's ready for a calculator, and that's when you punch a calculator. So let's go. So that would have given us x as 49.307, and that's pretty easy, straightforward. Obviously, remember, you might have been asked to round off to 1 decimal place or 2 decimal places. That's perfectly fine, and you round off accordingly. Something else that is important in grade 11, your CAS diagram. What is it used for and how is it important? The CAS diagram helps us to determine the solutions that would have fallen in other quadrants. For now, for purposes of this video, we're only looking at solutions from 0 to 360, and that will be easy, straightforward. We will later on in the other video talk about solutions that go up to negative infinity or that go up to positive infinity, and that's where the general solution comes in. So we know that in the fourth quadrant, only cos is positive. In the first quadrant, all of them are positive. In the second quadrant, only sin is positive. And in the third, only tan is positive. Now you want to keep this in mind, but over and above that, you also want to remember your reduction formulae, which will help you determine the solutions in those quadrants. Second quadrant 180 minus, third quadrant 180 plus, and fourth quadrant 360 minus. Okay, remember in South Africa, for purposes of our curriculum, in the current curriculum, we don't use 270. They used to be in the old curriculum 270 minus, 270 plus, but stick to these. They're pretty easy and straightforward because we're only doing three trig functions: sine, cos, and tan. Okay, that is in grade 11 and 12. So let's go. Now we're going to have to take this to some examples on trig equations. Take note. Sometimes you get told how far you need to go in terms of finding solutions. So it can be written in interval notation like that, 0 to 360, or it can be written in set Euler notation or inequality notation like that. It's the same thing. Let's bring in that CAS diagram. I want to have it next to us whilst we're busy solving. Look at the first example. Sine theta is equal to 0.794. This equation is ready for a calculator, and we have to find the reference angle. Take note, when you first punch your calculator, now you're going to talk about your reference angle. Sometimes other people call it a calculator angle. It's the same thing, it's perfectly fine. Shift sine 0.794 would have given us 52.56. Perfect. Now that's a reference angle. Where and how are we going to use it? Look at your question just before you punch your calculator. We have a positive ratio there. That means we need to look at the quadrants where sine is positive. Now that is the first and second quadrants. So our solution in the first quadrant happened to be automatically the reference angle itself. But in the second quadrant, we then use our reduction formula of 180 minus to help us determine what the solution would be in the second quadrant. So we just subtract our reference angle, and there's the solution. Done. So one always be able to remember that. Find out first which quadrants you're dealing with, and then use your reference angle in those quadrants. If it's the first quadrant, perfect. You do not go and use 90 minus. Your reference angle is the solution in the first quadrant. All right, let's look at another one here. Obviously, it's not ready for the calculator, so we manipulate that and transpose positive 2 to negative 2, and we get negative 2.428 divided by 3. Now we are ready for the calculator. Now be warned, in this method that I'm using here, the negative is just telling me which quadrants I'm going to have to look at. when I punch my calculator, I'm going to use a positive value of 0.809 just to find the reference angle. So I'll go shift cos positive 0.809. Okay, someone else would have used that 607 over 750, which you get on your calculator when you divide by 3. So that's perfectly fine. So reference angle 35.97 degrees, and remember, we've used the positive value, not the negative. The negative, we're just using it to tell us which quadrants we're looking at. So now we bring in the negative. The negative is telling us that we're looking for solutions in the quadrant where cos is negative. Oh, perfect. That's the second and third quadrants. So let's go. In the second quadrant, that's 180 minus our reference angle, and that then gives us 144.03. In the third quadrant, that's 180 plus our reference angle, and that then gives us 215.97. So can you see, if you keep this as basic as it is, you never have a problem with your trig equations. Okay, very, very important. Okay, more examples. Doesn't matter how they give you, the method is still the same. Just get your equation to be ready for the calculator. Sometimes you may divide and not necessarily get the simplified version of it, which is perfectly fine, and that gives a more accurate answer in terms of your calculations. Again, here we're dealing with quadrants where 10 is negative. When we punch our calculator, it's just shift 10 and 6√3 over 5, and we get a reference angle, and then we use that reference angle in the quadrants where 10 is negative. That would be the second quadrant, 180 minus. So 180 minus that gives us 115.69. I want to warn you quickly about a couple of things here. Take note of the fact that our angle is 2x minus 44. So that's the expression we're using to find our angle. So you do not do that with the reference angle. You do that in the quadrants where you are using your reference angle. So that 2x minus 44 degrees goes with us to the second quadrant where 10 is negative. And we have 2x minus 44 equals 180 minus the reference angle. And then you solve accordingly, and then you get your answer. You don't have to show us some of the calculator work. It's unnecessary steps. Okay, and notice I've also not labeled the quadrants. We already know which quadrants you would have been working with, so you don't need to show us anything except the calculations. Same thing, we go to the other quadrant where 10 is negative, and that is the 360 minus quadrant, which is the fourth quadrant. Same thing, we use our 2x minus 44 degrees in that quadrant as well, and we use 360 minus the reference angle, and then we manipulate our equation and we get our answer easily. So take note of things like that. Very, very important. Okay, do not use that whole thing of 2x minus 4. That expression is representing our angle, so we take it and go use it in the quadrants. Okay, and not with the reference angle. Okay, here's another one. Again, dividing both sides by 2 because you know it's not ready for the calculator. But again, take note, our angle is 3x minus 15 degrees, which is perfect. And then we go and use our calculator, punch it as it is, gives us a more accurate answer for our reference angle. We then take 3x minus 15 degrees to those quadrants where cos is positive, and that is the first quadrant and the fourth. So first quadrant, we want to use our 56.26 as is. I just want to show you something quickly. Other people might have simplified that 1048 over 2 and then get a rounded off a simplification of that. It's still fine, acceptable, except that just adjusts your answer a bit, because look at the reference angle that we get there of 55.94, because we're using 0.56, having rounded off, and we haven't got the other digits because of the rounding. So want to watch out for that, but it's perfectly fine. It's still acceptable in your calculations. So we go to the first quadrant and we use the reference angle as is. Take note, you do not go and use 90 minus, no. You use the reference angle as is if you're dealing with the first quadrant, and then you get your solution. In the fourth quadrant where cos is positive, we again use our reference angle of 360 minus and then solve for x, and we get our answer. Okay, pretty easy, straightforward. Just remember quadrants, your reduction formulae, and which quadrants you're dealing with in terms of being negative or positive on the ratio, and that you'll only check in that step when you're ready for the calculator. Okay, now warning, there are times when your equation has no solution. Just want to quickly look at that. Look at this equation. So we divide both sides by 2 and we get 2,2 there. And what happens? When we punch your calculator, you're going to get an error. That's because there's no solution in that equation. There's no value of theta that will give us 2,2. But why is that the case? The same thing happens in our example 2 there. We've got 2,59. There's no value of cos that will give us 2,59. Now, we need to explore this. If you know your trig graphs that represents these two trig functions, well, by the time we punch our calculator, we're actually looking at a basic trig graph. Now, a basic trig graph for sine and cos has a maximum at 1, meaning nothing beyond 1 is appearing for the graph. We've got a minimum at -1, meaning nothing below -1 appears. So our graph starts at -1 up to 1 in terms of the values we're using in our equations, which is exactly what we're doing in equations. The value we see there actually represents y. So our y is greater or equal to -1 or is less or equal to 1. So therefore, whenever we have an equation at the step where we're about to punch a calculator, remember, this is at the step where you're about to punch a calculator and get your reference angle. If that value on the other side is greater than 1 or is less than -1, there's no solution. You don't need to show us anything. Just write no solution. But that is when, after you've manipulated your equation, and now you're at the step where you're ready to punch your calculator. Okay, that's it. Those are basics. The next video will deal with the general solution of trig graphs. I hope you understood this. Okay.